Okay, all right. So you guys are gonna do 2 warm-ups. We're gonna do 9 and 11. In case you already did number 9. But for some reason, when I show these, people are like, oh, that's not bad. And then when I show these, which is significantly less work, people are like, oh my God, it's so terrible. I don't understand why, but that's fine. So we're going to do these 2 in the next couple of days. Hopefully it will be better. Okay, so you're in row 4. You can tell because of the 4 on the exponent. So it's going to be 4 combination something. And you have to remember that the rows all start with combination 0. So if we want the third one, we go 3 minus 1 is 2 for combination 2. Okay, then I'm going to put the front seat thing in parentheses and the back seat thing in parentheses. So front seat is y, back seat is negative 4x. Are you with me so far? Okay, the back seat thing has to have the same exponent as whatever your combination is. So for combination 2, that means the back seat thing will have an exponent of 2. And the front seat thing will have an exponent that has to add to a total of 4. So that one is also 2 in this case. Does anybody need me to say where I got any of that stuff from again? Are you sure? Okay. All right. For combination 2, I believe is 6 times y squared times 16x squared. If you screw this problem up, it's probably because you put 4x squared or you put 16x there. But you got to do both things. Also, you know, I don't know how many times I can say it in one school year, but when you square a negative, it becomes a positive. 16 times 6, I think, is 96. 96 x squared y squared. And I don't worry about if you put these in different order. I'm just a weirdo and I like them in alphabetical order. If you put y squared, x squared, it's totally the same thing. Any questions? Any questions about number 9? I think this is easier than this. I don't know. But we all know I'm special. Okay, flip the page over, go to number 11. And we have some natural log and e problems here, which is great to practice before our quiz tomorrow. So -1, negative 3.6 e to the x minus 8 equals negative 44. Do you know why I went out to 4 decimal places? Anybody know? What does this say? 10,000th place, which is 4 decimal places. Okay. So that stuff's, you know, all normal algebra. Now we have an e to an exponent is a number. We're going to natural log both sides, bring the exponent in front. I like to put the exponent in parentheses to protect it from any shenanigans. My one piece of advice for myself for next year is to space these problems apart more because my goodness, there's a lot of space on this page. I don't know. Okay, natural log and e cancel. 10.503. 10.503. No. 3. Okay, do we need to go over what grade is this? Second? No. Fourth? Okay, so what you do is you go to that decimal place and then you look to the one to the right and you say, oh, is it between 0 and 4 or 5 or higher? And if it's 5 or higher, then this one goes up. 10.5033. All right, now do not put your packets away today. Crazy town. I need you to find the first piece of dot paper. Right after your homework from last night, you have some dot paper. Just grab we're only going to use the first one today. Also, you're going to definitely want some kind of straight edge today. So if you don't have a straight edge type device on you, you're going to want to go over to the table over there, grab a ruler or protractor. All right, guys. Today is a very, very visual based day. There's nothing really challenging today. It's extremely easy, unless you have like difficulty seeing things 3D. So like there are people whose spatial awareness is a lot better than other people. If you're like not great at the geometry part of math too, that might be an indication that this might be challenging. Because shapes, but I think this is easier than any of that. And today really is just like sketching and modeling and talking about a 3D situation, which we haven't really graphed before. Homework is, I forgot to put the one to skip. So it's 56 to 62, but you're supposed to skip 60, I believe. 56 to 62. Okay, and then the square root of -1 is at the psychiatrist's office, and he says, do I really exist? Do you get it? Because he's I. Yeah. And the therapist guy, he looks a little baffled about what to say there. I think he really exists. Okay. I don't know about you, but I love it when there's a skip one in there. It's good stuff. Okay, well, you guys set up your notebooks. I'm gonna bring you some fun arts and crafts type things. No. Really? You guys need a third one so you can. Yes. Okay, so the first thing I'm giving you is an XYZ axis, which is fun. Fun fact, you're supposed to like cut these out and tape them and whatnot, but I found these in the cabinet when I found the screamer. And somebody made them out of cardstock, and I'm pretty sure it was Miss Cinema. But I sold them and gave Miss Rice the other ones, and now we're set. I know. I'm gonna bring you guys some snappy cubes also. Everybody got snappy cubes? No. Price is scrolling. So you guys should have one set of axes for 2 people and one bag of snappy cubes for 2 people. Okay. Are you guys set with your notebooks? Okay. This is one of those days when we actually have to like read the ebook. Okay. One sec, it's in the wrong thing. Okay. 49, the following questions ask you to consider when it is appropriate to graph an equation in 1, 2, and or 3 dimensions. It may be helpful to think about your experience representing numbers and relationships on a number line or an XY plane and how you can adapt your knowledge to work in 3 dimensions. Discuss each question with your team before writing your response. How can you represent the solution to x equals 5 graphically? Can you think of more than one way? There's 2 ways that you should be able to graph x equals 5. Just plain old x equals 5. Anyone have any ideas? There's 2 different ways we could graph x equals 5. A line, okay. So a vertical line on an XY axis is one of the ways. How do we graph things in 1 dimension? This is a 2-dimensional thing, XY axis. What's a 1-dimensional thing? A dot. Beautiful. Bryce is here. We're saved. Okay, so this is 1-dimensional. You can get a vertical line on a 2-dimensional thing, which means it's just going straight up and down, or you could get a dot on a number line. Those are both 1-dimensional options. Now we're going to move to 2-dimensional. This is still math 1 here. You guys know what that is? How can you represent the solutions to x plus 2y equals 5 graphically? What is this? It's a line. Okay, however, there's 2 ways to graph this line that I want to talk about here in this little spot. How can I graph this? Don't say with Desmos. Don't say with a graphing calculator. How can I graph this? There's one that's going to work for us and one that's not, but how do I graph this? Kind of, but how do you get it to do that? What? Oh, yes. Okay. Get Marisol got it. Get y by itself or y equals mx plus b. That's probably the way that you would go for if you had to, if you're like forced to do it. There's another way to graph this though that's actually much more helpful for this particular lesson, and that is x and y intercepts. We haven't done a lot of that this year, and that's why I'm giving you that answer. Okay, let's talk about what the x and y intercepts would be for this. So I use, when I'm teaching math 1, we use x and y intercepts in that class, and I teach them the patented Mrs. Talbot cover-up method. This is the laziest way to do this. So if I cover up the x thing and I divide by 2 on both sides, what is the value of y? 2.5. Okay, so that would be the coordinate 0, 2.5. Okay, and if I cover up the y thing, what would x be? 5. And that would be the coordinate 5, 0. And you can graph the coordinate 5, 0, and graph the coordinate 0, 2.5, and connect the line and make a line. Okay, now this is new. What I want you to do is take 30 seconds in your groups. I want you to Google, I'm serious, get your phones out or your Chromebook and Google, what shape will this make? Type this in to Google. Figure out what shape that's going to make. You've never really worked with that shape before. Go on a research mission for 30 seconds. It says x plus 2y plus z equals 5. Did you figure out what shape it makes?
I did. It's like a cone, right? This is a cone, right?
Yeah, that's not what shape it makes. X plus, maybe we can't trust the Google. No. No, no. I guess maybe we can't trust Google. It's supposed to make a plane. No? Okay, can you guys not throw the things? That'd be awesome. Okay. Here's the shape of it. So Desmos, if you go to desmos.com/3D, it has a super cool 3D graphing tool. I typed x plus 2y plus z equals 5. And the cool thing, there's so many cool things about this, but you can actually pull it and rotate. This is called a plane. A plane is a flat surface, not like an airplane. It's not an airplane. It's a plane. A plane is a flat surface that has no thickness. So if I'm supposed to be able to like pause, oh, there it is. No thickness. It goes on forever in all directions. So it's a 0 thickness surface that goes on forever in all directions. This is the graph of x plus 2y plus z equals 5. Okay, so Okay. Number 50. To graph solutions to equations with three variables, you need to use a three-dimensional coordinate system. Obtain a blank resource page. Okay, you have it. It's the yellow thing. If you guys could grab your yellow thing. And I want you to orient it just like this towards yourselves. That's why I gave you two of them if per table. I want you to have the x-axis on the left side, the y-axis on the right side, and the z-axis going straight up. So it should look something like this. With your team, locate a point where the x and y axis intersect. What do you think the value of z is at this point? 0. Beautiful. Okay, so this is the point where the x and y axis intersect. And this point is also z equals 0. This is the origin of your three-dimensional axes. And so 0. And how we write it is like this: 0, 0, 0. The x comes first, then the y, then the z. Any questions about number 50? It's my favorite problem of the day. I love it. 0, 0, 0 is right there. Okay, 51. Place a small marker. Don't really like make a mark. Just like, okay, take your pencil and on the bottom surface of your model at the point where x is 4 and y is 2. Now lift your marker straight up so that you're holding it 3 units above the bottom of the model. Okay, so we're going to go where x is 4, y is 2 is right here. X is 4, y is 2 is right here. Does that make sense to you guys? Okay, and then lift it straight up so that it's 3 units up. Let's see if I can do this better. So 4, 2, 3. This is challenging to do on a camera. 4, 2, 3. See, like it's hovering in the air. 4, 2, 3. Okay. What did it say to do with that information? With your team, decide how you can write the coordinates of this point. That is not really a shocking statement. What do you think? 4, 2, 3. So just remember, it's alphabetical order: X, Y, Z. These problems are amazing. Now locate the point where X is 3, Y is 4, and Z is 2. Use your team's method to write the coordinates for this point. Ooh, challenging. 3, 4, 2. Okay, I'm going to write it first. Okay. 3, 4, 2. 3, 4. Siri. 3, 4, 2. Okay. Now, this is a fun question. The next one might be my favorite, like, intellectual question of the day. Here's the question. How many of these do I need to be able to show the entire 3D coordinate system. How many of these do I need? And remember about negatives. How many of these do I need? Think about it in your groups for 30 seconds. Hold on. This one's coming apart. I'm saying, hold on. It's 8. It's 8. So here's 4 of them together. You could kind of see the top part, and then I would need 4 more on the bottom part to show. So these would be all of the top ones, and then I would need 4 more for the bottom to show the bottom one. I actually stole something else kind of cool out of the teacher's lounge. I've really been stealing stuff out of the teacher's lounge. Mrs. Aragon also made this. This is a plane in a 3D coordinate system. So you can see 1, 2, 3, 4, and then if there was a back, 5, 6, 7, 8. But yeah, Mrs. Aragon, crafty, really. She retired. So I just stole her things. Also, just in case you were wondering, I just bought a bag of spider webs and spiders so I can fix the screamer. It's gonna be good. Okay. Okay. All right, now we're gonna get to the part where we use the cubes. #52. Use cubes to build each shape described below inside your 3-dimensional model. Make sure that one corner of each shape you build lies at the origin at the point 0, 0, 0. Build a 2 by 2 by 2 rectangular prism. Use coordinates to name the vertex that is farthest from the origin. Okay, so I'm gonna take my cubes. There's enough for 2 sets of cubes per group, so you can break it up so that you each have 8. You need 8 to make the thing. 2 by 2 by 2. Yes, you do. There is nothing wrong with that. It's wonderful. We don't ever get to do this. All right, so here's my groups. Isn't it wonderful? Okay, so once you get it built, what we're gonna do is name coordinates. So we all decided that this coordinate in the corner is 0, 0, 0, correct? Yes? Okay. So what is this coordinate right here? 2, 0, 0. Do you see that it's 2, 0, 0? Okay, what's this coordinate over here? 0, 2, 0, nice. What's this coordinate back here? Gorgeous. Okay, what's this corner here? 2, 2, 0. And what's this coordinate here? 2, 2, 2, gorgeous. You guys are so amazing. Okay, now what the heck did it want us to do? Oh. I believe the final answer was to identify the 2, 2, 2 coordinate. We did more than we had to. That's fine. Okay. B, build a rectangular prism that is 2 units in length along the x-axis, 1 unit in length along the y-axis, and 3 units in length along the z-axis. Use coordinates to name the vertex that is farthest from the origin. Okay, 2 along the x-axis, 1 along the y-axis, and 3 along the z-axis. These hurt my fingies. There's mine. All right. Questions. What is this coordinate here? Two, zero, zero. Beautiful. What's this one here? 0, 1, 0. Gorgeous. What's this one here? 0, 1, 3. Okay. And this is the actual question. What's this one here? 2, 1, 3. C, draw and label a three-dimensional coordinate system on isometric dot paper as shown at right. Now add the prism from part B to the drawing. On your dot paper, label the coordinates of all of the vertices. Okay, so heading over here, we're gonna fit 2 graphs on this dot paper today. There's extra dot paper in your packet just for any mess ups or anything. I'm gonna work in erasable pen just because. Okay. So this is when you want your straight edge. Over here, put 11-52 C. Okay, and what we're going to do is we're going to go kind of in the middle here. We're going to start with the Z axis. I think I did 5 or ish. I'm just trying to stay in the top half of the dot paper. We're gonna do a second one in the bottom half of the dot paper. It doesn't have to be exactly like mine because I don't know if you noticed, but our prism is quite a bit smaller than the amount of dot paper that I have used here. Now you guys are like, oh, I see why we have this crazy dot paper in our packet. Okay, and what we're gonna do is we're going to sketch this situation here. So you want to come out 3 boxes on the X, no, lies. It's only 2. 2 boxes on the X axis. This is why we have erasable pen. So 2 boxes on the X axis. So this is basically like the bottom floor. And I went 1 this way for the Y axis. So this is my X and Y. And then I want to go up 3. Jocelyn should teach us this part. I should step aside. All right, so we're supposed to label the coordinates. It's going to be kind of challenging. So I'm gonna make arrows. So this is the origin. I'm gonna start with that 0, 0. Zero, zero. Mostly just challenging because all these other dots are in the way of what I'm writing. Not because it's challenging to write the coordinates, but okay, so that guy right there is 0, 0, 0. This guy right here is 2, 0, 0. Guy at the top up here, 0, 0, 3. Do you guys know what this one is? What? I didn't hear it. 0, 1, 0. Great. This is so fun, Mr. Knight. Okay, what's this one? Oh my gosh, there's no fooling you guys. Okay, you guys finish it. You need 2 more, I believe. Yeah. Oh, you need 3. I forgot about the actual one that the book wanted. All right, let's see. This guy is 2, 0, 3. This guy is the one we actually 2, 1, 3. 2, 1, 0. Did I get them all? There should be 8, because there's 8 vertices in a prism, rectangular base prism. Okay, we have one more, but we don't have a lot of time. So quickly make yourselves another set of axes below. We only have a couple of minutes. It doesn't, same as the previous one, it doesn't matter. But there's a very important lesson that we need to learn in number 54, but it's very quick. Okay, so we're going to plot this point. 0 on the x, 1 on the y, -1 on the z. Does that make sense to you guys? Do you see it? 0 on the x, 1 on the y, -1 on the z. Okay, now we're going to graph a different one. There's supposed to be a thing here. 1 on the x, 2 on the y, 0 on the z. Okay, now in your mind, are those two really the same thing? What's happening here with the paper? What? Yeah, we're applying a 3-dimensional thing to a 2-dimensional paper. It looks like on our paper that these two are the same coordinate. Okay, how do we fix it? This is the lesson for number 54. Number 54 is when you're graphing coordinates, use arrows. That way the teacher can tell that you're doing the right point. So let's do the first one. 0 on the x, 1 on the y, -1 on the z. This will tell your teacher that you know what you're doing. Do you see what I mean? So when graphing 3D, you guys want to do arrows. Okay, now we're just going to finish up what the notebook said real quick. This is it for the graph paper. You guys don't have to write this, just write dot paper. If we were to graph this one, we just don't have time, but if we were to graph this one, it actually would look like exactly the same spot as the other two. And they would all look like they're in the same spot, but they're not. So we come to the conclusion that we need to use arrows when graphing 3D points so that